2, 1. We have this.
March 2025. SpaceX's Starship exploded in a fireball mid-air. Critics called it a failure. Skeptics said the dream of interplanetary travel had stalled. But Elon Musk and his team didn't flinch. They went back to the drawing board, tweaked the systems, fixed the flaws, and now it's back. This is the story of Starship Flight 9, the mission that could change the future of spaceflight forever. Why does this test matter? What went wrong before, and what's at stake now? Buckle up. We're diving into the technology, the risks, the history-making potential of the most ambitious rocket humanity has ever built. March 14, 2025. The sky above Boca Chica, Texas turns electric as SpaceX prepares for its most ambitious test yet, Starship Flight 8. But minutes after liftoff, everything goes wrong. The Starship spins out of control midair, then explodes in a fiery blast. The mission ends not with triumph, but with debris raining into the Gulf. To the outside world, it looked like a catastrophe. But to SpaceX, it was a lesson. Because in spaceflight, failure isn't the end. It's just step one of getting it right. Why build a rocket this massive, this complex, and this risky? Because Elon Musk and SpaceX believe our future depends on it. Imagine a world where humans don't just live on Earth, but also on the Moon, Mars, and beyond. That's not science fiction, and it's the goal. And to reach it, we need a rocket powerful enough to carry cargo and people, yet reusable enough to make it affordable. The result? Starship. A rocket that looks like it came straight out of a 1950s sci-fi film, but is built on some of the most cutting-edge physics and engineering in the world today. Let's break it down. Starship is actually made of two main parts: the Super Heavy booster and the Starship upper stage. The Super Heavy is basically a flying skyscraper, powered by 33 Raptor engines. These engines burned liquid methane and liquid oxygen, a mix known as methalox. Why methane? Because methane can be manufactured from CO2 and water, using a process called the Sabatier reaction. And guess what? Mars has both CO2 and ice. This isn't just a rocket for Earth, it's a rocket designed for other worlds. Once Super Heavy lifts Starship into the upper atmosphere, the booster separates and heads back to Earth, vertically landing for reuse. The Starship upper stage then continues into orbit, capable of carrying over 150 tons, that's the weight of 30 elephants, into space. Flight 8 wasn't a complete failure. In fact, it performed beautifully for most of the flight. It lifted off smoothly, the separation sequence engaged, and it reached suborbital altitude. But during re-entry, a critical malfunction occurred. Hot gas leaked through the interstage, the area where the two rocket stages meet. That gas damaged vital components, and in seconds, the vehicle spun out of control. This wasn't just a mistake, it was expected. SpaceX has a saying, "Fail fast, learn faster." Flight 8 gave engineers precise data on aerodynamic stress, heat shielding, engine behavior, and structural performance. You can run thousands of simulations, but real flight data is irreplaceable. After the explosion, the entire Starship system went under review. Here's how Flight 9 improves on its predecessor. Interstage pressure equalization. Engineers added new valves and seals to prevent hot gas buildup. Redundant hydraulics. Now, backup systems will kick in if any flight surfaces lose pressure. Engine shielding. Raptor engines now have enhanced shielding to withstand both heat and vibration. Improved software. SpaceX upgraded its onboard AI with better anomaly detection, which can auto-correct flight paths in real time. These are not minor patches, these are deep architectural changes made in record time. Now let's talk about one of the most thrilling parts of Starship's flight, the landing flip. Most rockets land vertically using retropropulsion. Starship? It falls horizontally, like a skydiver, using 4 steel flaps to control its descent. Then, seconds before impact, it does a sudden flip and fires its engines to land upright. Why land like this? It's all about energy management. The belly flop allows Starship to use atmospheric drag to slow down, saving fuel for the final landing burn. This maneuver has never been attempted at this scale. It's part rocket science, part aerial acrobatics. The average cost to launch a kilogram to orbit today is around $10,000. SpaceX's Falcon 9 dropped that to $2,000. But with Starship, Elon Musk wants to get it below $100. That's not just impressive, that's world-changing. It means we could launch massive space telescopes, entire moon bases, interplanetary habitats, and deep space missions at a fraction of today's cost. Starship could do for space what the railroad did for America, open up a whole new frontier.
Stage route is go for flight.
Flight 9 isn't just a launch, it's a systems test. And every stage is designed to gather critical data, liftoff, and max Q. How the structure handles the most intense pressure, booster separation and return, proving Super Heavy can survive and land again. Orbital insertion, ensuring Starship reaches stable low Earth orbit. Re-entry and heat shielding. Testing over 18,000 ceramic tiles under hypersonic heat. Controlled splashdown near Hawaii. A full test of flight control and recovery. Each milestone brings us closer to full operational missions. First to the moon through NASA's Artemis program, then to Mars. This isn't just about rockets, it's about human ambition. If Flight 9 succeeds, it proves that a fully reusable methane-powered interplanetary-class vehicle is not only possible, it's real. And if it fails, SpaceX will take the data, tweak the design, and launch again. We are watching the birth of a system that could, within our lifetimes, make Earth to Mars cargo delivery a reality. SpaceX isn't just chasing the stars, it's building the highway to get there. Flight 9 isn't just a test, it's a symbol of relentless progress. Whether it soars or stumbles, it brings us closer to reusable rockets, Mars colonization, and a truly spacefaring civilization. If you're fascinated by what SpaceX is doing and you want more real science stories and mission breakdowns, this is the place for you. Subscribe for weekly space updates, deep dives, and science you can trust. If you enjoyed this, give it a like and drop your thoughts in the comments. Until next time, keep looking up.